Hello, Miss Howout, and welcome to Color Guard in Chemistry, Bonding Edition by Brigette Laramee. Today I'll be demonstrating the process of ionic bonding, covalent bonding, metallic bonding, and as well as the importance of valence electrons. Valence electrons are the electrons located on the outermost shell of the molecule. These electrons will be gained, lost, and shared in order to be bonded. We can relate this to weighting an end cap to a flag. Here we have the bolt, which is the innermost part of the end cap, kind of like the nucleus. Next we have our electrons surrounding our nucleus. We have a shell here, our next shell here, until finally we reach the valence electrons. Note that the valence electrons are what bond the other molecules together, just like the tape is what bonds the end cap to the flag. Next up we have ionic bonds. Now ionic bonds are between a metal and a non-metal. And what happens in ionic bonding is the valence electrons are shared together in order to get a full valence shell, so that way they're all happy and stable. I will be using NaCl as my example, and as a note, every half spin is equal to 1 electron. Those we saw that the elements standing on their own are perfectly happy. When bonded together, if their valence electrons did not share, you can see they're not as happy. But if they share their electrons to get a full valence shell, everything works out fine! Next we have covalent bonds, which will actually share their electrons rather than borrow. Here we have F2, and when all calculated out, each fluorine will have 6 electrons surrounding it, as well as a line in the middle which represents 2 fluorine. This worked out totally fine because each fluorine is surrounded by 8 electrons, so they're all happy. That's not necessarily the case for, let's say, O2. But the way O2 is calculated out, it winds up having 1 oxygen with full valence shell, but the other only having 6 electrons. So, oxygen will share a pair of electrons to form a double bond, so that way they both have 8. Now, in metallic bonding, all of the metals are positive, so how do they stay together? Well, if you have one metal here, you have the electrons surrounding the metal, that will attract another metal because positive and negative, which will attract another metal with those electrons. So now you just have this clump of electrons, and that is called the sea of electrons. So even though we're the same, we're being held together by the sea of electrons, or in this case, counting. And there you have it. Now if you don't mind, my tiny flag and I will be off to class.